Good evening, everybody. I'm Chris Lambell from the Electrical Engineering Group, and welcome to the Day in Life Electrical Engineer. This is our, I'm going to say annual, it's our second one, but we've only been going 2 years, so it is our annual student-focused event where we're trying to encourage people to become electrical engineers, whether that's from a student like academic background, or perhaps you're in another industry looking to make a change and head into electrical engineering. And most people think electrical engineering is lots of money and supercars, but it is that, and there are other aspects to it. So, well, I've got a captive audience. I'm going to make a plug for a few upcoming events. 28th of April, we've got Evans from Wellington Electricity talking distributed energy resources, connection, challenges and opportunities. That's 2 weeks away. The 19th of May, we're lucky enough to have Hamish McLean of Fuel Chief, who's going to talk on generator fuel storage for critical infrastructure. That should be a good one. 28th of June, we've got Carl Rove Gallagher talking access control. Now, this is our first by request. Carl comes back on, does a second on lock technologies. 14th of July, we've got Schneider back again. That's a mixture of Moomin and Mark, talking on discrimination and cascading, which is a kind of a core fundamental, certainly to building services, electrical engineering. So that's a few events which you'll hopefully join us for. But tonight's event, so we're lucky enough to have 3 presenters, so we're going to do 3 presentations, somewhere between 5 and 15 minutes each, but it's more about the content than the duration. If we hold all questions to the end, we'll have a mixture of online questions, which I'll read out aloud, and we'll pass the microphone around if people want to ask questions in the room. So tonight our 3 presenters are Neo, from Building Services Engineer from Becker here in Wellington. We've got Georgina Price, who's the Power Systems Engineer from Becker. Chris Ely in the middle there. Well, I suppose he's the only boy, so it's going to be in the middle. From Building Services Electrical Engineer from NDY here in Wellington. So just to be clear, it is obviously nervous talking in front of a lot of people. I know there's a few nerds here tonight, but everybody's to a degree volunteered. Whether they volunteered or they were volunteered, that's probably up for debate. But yeah, so go easy with everybody. It's not easy sitting up the front here. So I'll hand over to Neo.
Cool. So I'm Neo. I work at Becker. It's been a little background about me. I was born in Auckland, chose to come down to Wellington for an internship and ended up stuck here. That's a good thing. I enjoyed it. I enjoyed my time here in building services. So yeah, I hope you guys enjoy my talk tonight. And yeah, thanks for coming along. So what I do a typical day as an electrical engineer under building services. So we do a bit of electrical distribution. We design the electrical distribution within a building. That involves lighting design, obviously electrical, lightning protection, communication design, security design, automation, anything electrical really, that like vertical transportation, lift transportation. So this here is one of the tasks I'll do, like not every day. There's no such thing as a typical day as an electrical engineer in building services. The only typical thing is getting into work, reading emails, writing your task, and that's it. Like the rest of the day is whatever project is urgent that needs to go out. That will be first on the task list. But this is one task that I would work on, which is building a PowerCAD model of a building. This involves cable designs, cable calc designs, measuring the lengths from one point to the other, adding main switchboard, how it goes from main switchboard to distribution boards. Yep, that's power. We do a bit of in concept design. We have this here, which involves lighting power calcs. Like we get information from architects, but it's not like set in stone. So we just like estimate, depending on the information that they've given to us, what that room will need. So we get a meeting room. We try to figure out if it needs a certain lighting, try to try to meet standards such as ACE, NZ 1680. And then we have another stage, which is more set in stone. So this is our concept. Yeah,
prelim design.
Oh yeah, our prelim design. Too many technical design stages. So this is where we expect architects to tell us where they're going to put certain electrical structures, where their tables are going to be set so we can supply power at a certain reasonable location. And then we come to detailed design, where everything is set in stone. We start circuiting and calculating the load needed in that building, in that room, and design our power at the end, the total load for that building. And then this is a lot of what I do day to day, which is a lighting design. It can either be indoor or outdoor. So we use a software called AGI 32, and that involves choosing the luminaires, talking to suppliers, like trying to find the best suitable fitting for that room. A lot of coordination communication is involved here, where we had to talk to suppliers or to the clients to see what their lighting requirements in their room is. And then after design is done, we're ready for construction. So I've been in Baker for just over a year, and I've been to one site visit, which was, I think I shouldn't say, because that one site visit I went to with an electrical engineer, we saw someone standing on a new cable trays, and they were on live wires. I was just like, oh, what an experience. My first site visit was seeing someone standing on live wires and new cable trays.
Sometimes bad experience is just as good. You see what you shouldn't be doing. Hopefully you saw what you shouldn't be doing.
So yeah, it was an interesting experience. Our site meeting involved our client, contractors, and as soon as other contractor that wasn't in trouble, wasn't in the room, we had to speak up about it and tell them that this happened. We didn't want to embarrass that contractor, so kept it on the low. We do RFIs, so request for information. If contractors during construction stage have issues or come up with fire complications or design failures, they send us questions. We try to respond as soon as we can within a week. We do shop drawings, checking the drawings if going onto site, making sure that everything we've designed is what they've constructed. If there's any issues, there's always a lot of communications involved. Sometimes the client changes the design, so when the building is built, they can envisage what their room is meant to be like, and then end up changing what they want to do with that room. So that's something that we had to also work on and listen to the client, because they're the one paying us. We also do defects inspection, where we go in, we check if everything in design is working, basically. So here's a PowerPoint. We check if they're tagged with the correct tag, making sure that the circuit number is on it, making sure everything is working fine, the design doesn't look messy, because you give a design to contractors and they just do whatever they want with it. So you always need to check that they did what we expect them to do to the best of their quality and what our high expectations as well. We check switchboards as well, making sure they function appropriately during commissioning, which involves switching off certain things, trialing if you switch off one distribution board, what happens to the rest of the building. And yeah, this is where I work most of the time, 90% of the time. Oh, this is not my table. This table was cleaner, so I took a photo of my colleague's table. And yeah.
It's not my desk either, by the way. Mine's not that clean.
This one's worse. I work with a colleague who bakes, so also another fun thing. This was one of the projects that they worked on, and yeah, celebrated with this at the end. Thank you. Pass it over to Chris.
Thanks, Leah. Done. That's the hard part over now. Thanks, Chris.
All right, is it okay if I stand up? I won't be out of screen. Okay, I don't like sitting down too long. There we go. Chris Ely, A Day in the Life. I'll give you a brief intro about who I am first, and then we'll move on to the day in the life. So there goes my school, went to Otago Boys down to Dunedin. Then I joined the army out of school. Took a brief gap year at university, which didn't work out the first time. So yeah, I did some time in the army, and then while I was also in the army, I changed to being an electrician. And if you go to the NZDF careers page and look up electrician, apparently I'm the only one there since there's 3 photos and they're all me. But they don't have me anymore. So then I went to Welltech, where I just completed my degree last year in a Bachelor of Engineering Technology in Mechatronics. And now I work at NDY. It wasn't all as clean cut into 5 different categories as that. I did work 1 day a week at NDY during my time studying. So it was a pretty smooth transition at the end of last year, coming on full time where I am now. Okay, so I'll move on. Day in the life. As Neo said, a lot of what we do is designing power and power distribution, lighting, communications and security for new buildings. Just got some pretty pictures explaining each of them up there. Also, like Neo said, I'll try not to repeat you on too much. A lot of what we do is governed by standards, and they are the minimum standard. You can't go below it. In a lot of situations, you want to go higher and you want to do better than the minimum. But that's the main one, what I would consider the main standard there, the AS/NZS 3000. Oh no, I just noticed that the picture I've got is 2018, which is the new standard, but New Zealand doesn't use it yet. So we're stuck in 2007 with our standard. But I used the wrong picture, but we'll move along. And there we go, the 1680, the lighting standards, series of standards. So there's a whole bunch of them for different tasks. At the moment, I'm working on a hospital, so I'm pretty deep into 1680 Part 5. And then there's many, many others. I'm not going to talk to you about standards all night, or we'll go to sleep. So the engineering part of it is a lot of calculations. We saw the power CAD before. That's definitely part of what we do. But before we get there, we need to know the loads that are going on each of those distribution boards. So we've got to calculate the maximum demand, which is an educated guess at how much power an installation might be using at any one time. It's if you go around a power point, each of them is rated to 10 amps. If you go into a room and add up, oh, it's got 10 power points, that's 100 amps. If you go to your house, you're going to be using a whole lot of power real quick if you calculate it like that. So there's a calculation in the 3000 in the standard that describes how much power we can expect that installation to reasonably use. So and a large part of what I'm doing is updating our spreadsheet, since they found out I love spreadsheets at work. So I've got a nice one full of drop-down boxes. So doing maximum demand calculations. Neo already went into lighting, so I'll just say I do those as well. Then we go into the design. So that's the power articulation, putting in cable trays, the design of the cable trays throughout a building, and how the power is getting to where it needs to be. For small power, so that's just the final use of power, I guess. For general purpose things where you're plugging it in, or an oven or something. And lighting, how power's getting out there. Again, we've got a nice looking drawing, lots of pipes and stuff. I'm glad you didn't have the same one that I Googled. And we do power supply modeling. So once we've done the calculations, it goes into PowerCAD and it all gets modeled. It would be very difficult, but it is possible to do these calculations manually and these modeling manually. And that's a lot of the older guys at work. They're big, what's the word I'm looking for? They're big fans of knowing how to do everything manually. You can't go into a big building like this one, several stories, large spaces, and expect to do it manually. You'll be there for a long time. But you do need to know enough so that when PowerCAD's giving you crazy numbers, you know where you've gone wrong, what number you put in wrong. And so in theory, you should be able to do every calculation that you do. You should know how to do it manually so that when you're doing it with the automated way, it makes sense. And then the next part is Revit, where we go into the 3D model. So this is just a building infrastructure management, or BIM, product made by the same people who make AutoCAD. You probably that was probably more a name you'll understand. And it's actually going around in a 3D model of the entire space, putting out your PowerPoints and doing all that kind of stuff, putting where your light's going, that you've got the information from your PowerCAD model, from your lighting modeling, and you're integrating it all together into the actual 3D model, which is what gets built, hopefully. And then just going to say that it's really cliched, but it is super duper important. Collaboration, communication, and teamwork. If you just go sit in a little corner of the room by yourself and try and butt your head through all of the problems, you're going to have a really hard time compared to if you go around and ask people for help. I don't know what it's like in Becca, but every day, there wouldn't be a day that I've been at work, even when I'm working from home, where I haven't either approached one of my colleagues or been approached by a colleague for, oh, have you seen something like this before? Or, you know, what do you reckon we do here? And then like, oh, I think I saw something in the standard about that, because we all read the standard at night before bed. So yeah, so that's, yeah, a summary is those things. So if you went to engineering out of high school because you wanted to get a job where you didn't have to talk to people, I'm sorry. Communication, collaboration, and teamwork, very important. I think that's my last slide. There we go. I'll pass over to Georgina.
Cool, that was awesome, Chris. Just to say, it's probably a good thing you answered that that wiring rules yet thing, because we'd have like 20 questions at the end and saying you are aware that's not cited yet. So that probably saved you a number of questions. But great presentation. Good.
Just Google imaged and pick the. I just Google imaged and pick the first one every time.
So that was great. Okay, over to you, Georgina. Thanks.
Awesome, thank you guys. Just a heads up, I missed the memo around the timing, so mine might be a little bit longer, and it's going to be from a different perspective, so watch the space. But so my name's Regina Price. I'm also from Becca, so I know quite a few faces in the room. Nice to see a bit of support. Thanks, team. But my presentation is going to be a little bit different because I'll be talking about it from the perspective of a power systems engineer. And shortly I will explain what that means, because it's a little bit convoluted and up to interpretation, really. But without further ado, I thought I'd start out with a little bit about me. So I've been at Becca for over 2 years now. I went to the University of Auckland and studied electrical and electronics engineering and graduated from there and came straight to Becca. After my second year at university, I interned at Meridian Energy down in the South Island, working in hydro stations, looking at lots of water and how things spin and move water around, really. And then after my third year, I was at Becca as an intern, and they seemed to like me enough to recruit me back as a grad. So that was pretty cool. And I've been here ever since.
So yeah, and I'm also a Wellingtonian as well. So I've got the pleasure of having my physics teacher here from year 12 and year 13 in the room. So that's pretty cool as well. Hello. Just a bit about the photos that you can see there. The one on the left, you'll see I'm wearing TransPower stuff. That's whenever you go to most of their substations, they like you to wear their gear. So I haven't defaulted to TransPower, I'm still with Becca, but that's the sort of gear we wear. And that's at Naseby substation down in the South Island. And then on the right, I'm on site yet again, and that is at a confidential wind farm. And I've got a turbine tower behind me and something called a nacelle, which is that big white block, which basically sits on top of the tower and houses the generator that makes the thing, well, it doesn't make the thing spin, but it spins with the turbine. But yeah, that's a bit about me. So power systems engineer, it's a bit random and it sounds a bit made up, but it's a branch of electrical engineering, and like any electrical engineering, I like to think it's basically doing magic. It's pretty cool because we're not like bridge engineers or structural engineers. You can't see what we do, but what we do impacts you every single day. And it's a pretty magical thing, even just to have the lights on, being able to present this to you. I've got a wireless microphone. All that is electrical engineering. And power systems engineer is a higher voltage side of things, but we too, I like to think, are a bit magical in what we do. So yeah, typical day for me, I tried to sum it up in about 4 photos, so bear with me here. Top left photo is a 3D design. So most of our work that we're trying to do at the moment, although most of our substations and equipment can be dated back to like 1950s, we like to try and prove it where we can, and we make 3D design. And it's a really great way to communicate to our clients effectively and efficiently about what it is that we propose to do. So it's all great to have a 2D drawing and all, but it's really hard to get a bit of perspective about what it is that you're designing and portraying. So we're moving into the automation and 3D design space, and that model up there is actually one I did myself, and that's at Livingston Substation in the South Island as well, and that's about to be built soon, hopefully. Bottom left again is some turbines in progress. They're what we call hammerheads. So it's basically a turbine without a blade on it, and it just sits there until you can put some blades on it. But that's an aspect of my project life, because as soon as I started, I've basically been working on that project from day dot 2 years on. And I don't actually do anything technical in that area. Mainly what I do is in project management. So I actually look after the team internally, make sure things are delivered on time and effectively, and we're following code and representing our client, who is the one that owns and operates that wind farm. We do not, we operate on behalf of, well, we look after things on behalf of them, and what's called an owner's engineer role. So that's pretty cool to be involved in a renewable energy project, but not just technically, also project management perspective. So it's great to have a bit of flexibility in my role as well. A bit more technical is a cross section of a cable, which you can see there as well. So you use this real funky software called SimCap, and I have been using that for the past 2 years as well. It's a really clunky software at times, but it's bloody smart. It's quite cool. You can get a cable data sheet and you put in inputs from there. A cable data sheet is all the technical information you need for that cable, and you can build it up and then run it. And the purpose of that is that you can put it in. Say I'm designing a underground cable network, I need to know how that cable is going to perform in the soil and how it's going to look. And so you can put it in the ground, theoretically, and run it and see what sort of temperature it's going to run out, what sort of ampere level it's going to put out, and design it and change it accordingly. So that's quite a lot of what I do on lots of different projects as well. And then I thought I'd throw in something a bit fun as well on the right there. So it's not something I built, but my team built it. So I'm in the power team at Becca, and half of our team does transmission line engineering. And so quite a lot of us love to get together and work together to do things, not just in work as well. But that's something that we, they built around Christmas time, and it's our to scale transmission line tower. So yeah, very festive as well. I know I said power systems engineers are magical, but we're also kind of detectives. So I know that sounds a bit weird as well, but as I said before, you can get drawings and you can get substations and electrical equipment that date back to the 1950s, a long time ago. And quite a lot of the information you'll see on those old hand-drawn drawings is not quite up to date. And so you need to go to site and investigate what's actually there. So you get your little detective glass out, have a look at your drawing, have a look at what's up there. Is that right? I don't know. Take some notes and investigate it a bit more. And you try and confirm what you've got so that it's rated correctly. So a lot of what I do is also called thermal chain checks. That's a bit complicated, but essentially just checking that every single bit in that string of equipment is to the required ampere, that level that it needs to be. So you get to go and investigate, go on site, stare at things, go, oh, yep, that looks good, and test out the zoom strength of your camera, because that's fun too. But yeah, I thought I'd also give just a general overview of the New Zealand electricity network and where I sort of sit in this and where power systems engineers sit and where these guys next to me also sit. So you start off in New Zealand with generation. So that could be hydro, it could be wind, it could be the Huntly area. No, I don't like that. We're all 100% renewable positive in the power systems team. But yeah, so you start out generating some electricity and then you need to get that somewhere and you want to get it to your house. So the first stage after that is transmission. And so that's those massive pylons that you will see in the middle of nowhere. If you've driven the desert road, there's a lot of them there. We love that place. Like, we go there to photograph the towers. That's how much we love what we do. But yeah, so you transmit this high voltage electricity along those pylons. And then to get it to a more usable level, you need this intermediate step, which is called a substation. And that's where most of my design work lies. So that mainly takes your high voltage electricity and steps it down to low voltage electricity. And so you get it to a distribution level and it distributes that to your house. And that's how you can turn on a light switch. So yeah, that's how New Zealand works in a nutshell. But I thought I'd talk a little bit about some of the projects and problems that we solve in the power systems team, because engineers are, you've probably been told your entire high school, university life that we're all problem solvers, and we are. And this is one of the ones that I recently got to work on, which was quite special. So I like to think of, it's quite helpful to think of an electricity cable conductor as a water pipe. So that electricity conductor is designed to hold a certain amount of, like, water pipe. It's allowed to have a certain amount of water flow through it. So that works fine. It flows through. Eventually what might happen is, if you look at that down in the South Island, the very bottom, you've got Manapuri and then you've got a red massive dot next to it, which is a load center. That takes a lot of electricity. Let's say you take that out of the picture and all you've got after that is those skinny little black lines, which are smaller water pipes. You need to get a whole lot more water through those water pipes, and once that load center is gone. So how are you going to do that? And that's one of the things that we got to work on my team, is increasing those pipes or the conductors or rating of that transmission network and substations so that those pipes don't burst. So that's where this funky project comes in, called Clutha Upper Waitaki Lines Project, and you'll find out soon enough. Engineers love their acronyms. So we get CALIP, and don't ask me how it's pronounced like that, it just is. We've adopted it and we move on. But it's something that I got to be a part of. It's a real life solution and problem. It's happening at the moment, and it's something that affects every single one of you. So it comes back to that idea of magic. You don't know it's happening, you don't know it's an issue, but you're still going to get power to your house, right? It's great. we make that happen. Heaps of people make that happen. Again, I said earlier, we do a bit of 3D design. So for this CALIP project, we were able to illustrate to our client how we want to do what we want to do. So we can show the parts that we want to remove, and then we can step through it and go, okay, this is what it's going to look like. We're going to move some foundations here. We're going to whack in some new foundations and put some new equipment in, and voila, basically. We step through it and go, this is how we're going to execute it, what we want it to look like, and we hope you guys like it too, basically. It's quite cool. So yeah, that's the sort of 3D design that I've been a part of, and my team helped make that possible. To wrap it up, really, I like to say that power systems engineers, and what my day typically consists of, is that we're enablers. We don't, you don't know who we are, and you don't know that we exist, and that's fine, because I didn't either. I didn't know what a power systems engineer was until I started day one. So I was like, oh, that's a funky job title, but what am I going to do with that? but now when I think about it, we enable people. You don't know that we're here, but we're here and we do some great things. And it's also the same with the building services engineers who sit to the right of me. They're all pretty superb humans and we achieve great things. So yeah, it's a great day to be making every day better. Thank you. Thank you.
Cool, thought that was awesome. Thanks. I learned a few things. As a building services electrical engineer, I might look for a career change myself and look at the job going. Anyway, that's not the point tonight.
Join us.
Tempted to the dark side.
Yeah, it's a great side.
Any questions in the room?
Don't be shy.
Oops, hang on, we do have a question.
What would you say for each of you? What's the favorite part of your job?
Do you mean apart from getting there at 8:30 every morning? I just like the camaraderie and the collaboration and coming up with solutions. And I guess you can't, as Georgina was saying, when you're in the enabling business and people don't really know you're there, but when things go wrong, suddenly you're the ones that go to for solutions. So you need to be ready to, where am I going with this? You need to be ready to accept that you might not always get a pat on the back from somebody else, because if you do your job well, then they won't even know that it's been done. If you do your lighting well, people just work in a space and they work effectively. But if you get it wrong and they're getting glare in their eyes, then everyone's complaining about headaches. So until you do your job wrong, a lot of people don't know you exist. That's just my addendum to your people don't know you're there. The moment it goes wrong, they know.
Yeah, that's so true.
Yeah, like if you have a blackout, everyone knows who to look at then. But yeah, I think I'm going to be a bit cliche as well and say the favorite bit about my job is actually the culture that I work with. It's there's a lot of stereotypes and stigma around engineers, and I feel like that's quite unfair because the team that I work with are superb people. I hang out with them outside of work and inside work, and we do a lot together, and it makes the job really easy because you collaborate. And as Chris said, we do a lot together, and it makes the day go by. We always do the quiz together every day and stuff like that, just real mundane things, but it makes it great. And if you didn't pick up on my slideshow as well, I like that what I do is a big part of New Zealand and progressing to the future of New Zealand, like helping out in any way. If it's heading towards a 100% renewable goal or talking about what that means, what projects we can do to achieve that and make New Zealand more sustainable. I'm quite big on the sustainability thing, sorry. But yeah, I'm passionate about what I do, and so it makes it easy to get up every day and find purpose with what it is that I want to do. So just, yeah, something to think about.
What about you, Leon? To be clear, eating cake at morning tea is not included as being your best part of the day.
It's sausage roll, actually. No. No, it's culture as well, like they said. In building services, for electrical engineers, one part of building services. So I'm actually lucky I get to work with mechanical engineers, as well as plumbing and drainage engineers, fire engineers. So that falls under building services. So not only do we learn like electrical, we get to dive into a bit of everything because we need to coordinate with mechanical engineers as well as plumbing and drainage about everything. You don't want pipes going through my cable trays or like ducts going through like any of our cables. So a lot of coordination is needed. We need to like communicate a lot, and yeah, every day is different. Find something new every day.
Cool, great question. Any other questions in the room? So what have we got online, Holly? Oops, hang on, we've got one more in the room.
So I was kind of interested. So at university, we've been taught with software that you have agile methodologies and that sort of stuff for project management and software. And one thing that has been kind of not like glossed over is what sort of project management flow do you use as a power systems engineer?
Okay, I guess there's, well, the one thing that we use on our project that I work on is this fancy website called Aconex, which allows all aspects of the project to come in and communicate with each other. So you'll have your consultants, your contractors, your designers, everyone meeting on the same platform and discussing on the same platform. So that's probably the only process that we actually use that's defined. Everything else that for the project that I work on, I developed myself when we started. So like there's things called technical comments registers. So if you've got a query and it needs to be answered by the contractor, you put that in and answer it and you send it to the contractors and it comes back and hopefully it answers your question. If it doesn't, it goes back and it's a lot of back and forth. But yeah, there's a lot of opportunity in that space. And what you've mentioned is something I actually haven't heard of before. So it'd be quite cool to hear that's what we love to hear from graduates and university students is what they've learned and how we can integrate that into our processes, because we may have experience, but you guys have the new ideas. So yeah, just make sure you hold on to that and share that with your people.
So in terms of a process, it's probably, if you look at that sort of thing, it'd be a waterfall type process. If you're looking at agile and things, it's very much a milestone based, complete a task, get a sign up or approval of some form, then waterfall down to your next one. That'd be the overarching methodology. Now, perhaps within tasks, you could look at agile kind of scenarios, but the way we work, which is very tracking with a team to complete a task, then as an assessment based on cost, feasibility, etc. It's very much a waterfall kind of process. Our project management team use a lot of agile and Scrum and all those buzzwords, but certainly for us, it's a very linear kind of approval based process. No, I don't know if that answers your question. Any other questions in the room? Oops, hang on. You've got to speak on the microphone to be famous.
Really. Okay. Gina, often power systems engineers, when they're studying, TransPower automatically takes an interest in them. Did they propose to you soon after or before you even graduated with your qualification?
I don't want to badmouth TransPower or anything, but no, they didn't. I have not been approached by TransPower at any point in time. I'm
actually rather surprised. They have a tendency to pick out the power systems graduates as soon as possible.
Yeah, I too have heard that, but no, I think maybe because I was already taken by Becca because I did my internship in my third year, and then they were like, "Oh, can you come back, please?" I was like, "Yep, sure."
Probably they already thought, okay, you're invested with them, so that's why they left you alone.
Potentially, yeah.
Yeah.
But it's a very scarce industry, so it's you'll find that with most engineering.
Well, you three fine people won't be out of the job because the government's just realised you're at least $75 million. It's probably $75 billion in debt because their infrastructure's falling apart, and they've now realised, the pipes won't fix themselves.
Yeah, I will not comment on that.
We should. Why do we have to put up with the street erupting under us and poo water flowing everywhere? It's not good. We're in New Zealand.
No, I totally agree. But the thing is, well, without being mean to the council or the government, people only fund projects that they can see to a certain degree. And so you might want a pretty building or a cycle path instead of new improved waterways.
I was going to say we should be a bit careful talking about policy and things like that. I mean, which outside of our remit is very much. Oh, I mean, that is a risk. We need the right people in the right places thinking about that and putting investment in that place. I mean, nobody here is probably qualified to talk in that area, but we're quite happy to be involved in fixing it. That's probably the end result of it. Sorry.
Hello. How transferable do you guys think your skills are overseas, for example?
I had not put too much thought into it. I've just been enjoying not having to study at the moment. But if I was to look at it now and I'm thinking about it, I'd say there's no reason they can't be very transferable. But yeah, maybe one of these people have thought about it more.
Oh, yeah, I've definitely thought about it, but given COVID, not going anywhere. But yeah, there's so many different things that I could be doing out there. Like I know that in Canada, you can go work on HV testing rigs and go blow things up in the sea. that's pretty cool. You could go work in Sweden, you could work in Norway, UK, Dubai, anywhere. It's super transferable. And like I said, even though I did electrical engineering, I could still just go straight into project management if I wanted to. So it's very flexible even in your degree. So yeah, super transferable. It's a great degree regardless if you do electrical or not. So yeah.
Actually, in Becker, they encourage us to like go towards project management or like dive into like different parts. So as an electrical engineer, I was told if I wanted to like test out power systems, like go check out what they do, like spend a week down there with them. So yeah, I think it's quite transferable in a way. Like going overseas, we have Becker companies set up in Singapore or like, yeah, there's quite a few Australia. So yeah, I think it's transferable skills.
I don't share that policy. I want you to stay in Wellington as my team.
Yeah, me too.
That is my opinion, not that of the
I'm
company.
stuck here. In a good way, in a good way.
I feel guilty. Sorry, any other questions in the room? So what have we got online? Some.
I'm just. Oh.
I shall read them aloud.
Okay, so we've got a few questions here online. So we'll pass this through to all of you. If you could go back and do one thing differently at the start of your career, what would that be, if anything at all?
I don't think I would have dropped out of university the first time. Even though I did have fun, but it was a big 14-year gap year, but we can, oh well.
I don't know. I think what I would have done is had a look around a bit more. I guess I got, like, not saying anything bad about Becker, I love it. But after third year, maybe I shouldn't have gone straight into a graduate job with Becker. It would have been good to get a bit more experience and exposure to other things in the industry. So I don't know what it's like on the contractor side of life. That would be quite cool to know. And especially now in my role, it's actually quite good to know what it's like on the contractors side, so you can relate with them and communicate with them better. And so that's something I would do, is just get a bit more exposure and don't narrow yourself down straight away if you don't have to.
Yeah, mine will be the same. So on my team, we have electrical engineers, but we also had contractors come into building services. So their knowledge is quite different to a consultant building services electrical engineer, because they understand the contractor side. And as a consultant, like having that knowledge of both sides and understanding where they're coming from is quite like a good thing for everyone, like understanding how they feel about certain things. So yeah, maybe diving into the contractor side would have helped.
Cool, thank you. What extra subjects or subjects in general should I do in my final year of high school to help?
I wouldn't ask me, because I was one of those people that was like, I must do everything. And so I did. But that was quite overwhelming, and I guess my results struggled a little bit. For engineering in particular, the main ones to focus on is your maths and sciences. In first year engineering, no matter where you are in New Zealand, you'll do a general first year. So if you want to do whatever you want, so you need to have a little bit, well, you don't need to, but a little bit of background in chemistry, biology and physics, because there's aspects of engineering that are called chemicals and materials engineering, which requires you to have a background in chemistry. There's also biomedical, so you need biology understanding. So I wouldn't say rule them out, but if you know you definitely won't do them or don't like them, then don't do them. But yeah, I did everything. I loved maths. I did all the calculus, statistics, sciences, English, language, whatever. I loved it.
My pathway was slightly different to Georgina's. I guess I'm the success story from the other end, where even if you maybe come out of school and you don't do so well, you can certainly get in there later in life, and a lot of people develop a lot of maturity later and get the ability to study when they've got something to set their mind on. So don't feel if you're in your last year of high school now and you didn't do maths and that just aged me, I was about to call it sixth form, in year 12. If you didn't do maths in year 12 and you're like, oh no, I really want to be an engineer after listening to Chris talk, but I didn't do maths, don't worry, you can get there later in life, and there is a pathway.
Yeah, I had an odd journey as well. So I was forced to do certain subjects, but because I liked engineering, I just made sure I had my compulsory subjects on lock, which was maths with calculus and physics. So my parents expected certain things of me, so I had to do business subjects as well as try to put in my subjects that I enjoyed. So maths and physics, you'll still get through.
Cool. We've got a question for Neo, and as you've got the mic, how did you find entering the building service from electrical engineering background at university, as we are not exposed to a lot of the information surrounding distribution boards, etc.?
So with building services, it's a degree on its own in other countries. So what we do, what I did at uni, basically 5% of what I learned helped me in this role today. So I would say if you're worried about coming into the workforce, like especially with BICA, they teach you from scratch. It's like through experience you learn things.
Cool. Okay, a question for all of you. As a graduate, are you given exposure to client meetings and providing technical consulting, or is this handled more by your managers?
In my experience, it's definitely from day one, you're encouraged to be there, even if you're not the one asking the hard questions. You need to know how to interact with clients so that when you do get to that role, you're not suddenly in the deep end. So I guess in summary, yes, we are in meetings.
Yep, we're in meetings too. I often find that I have no idea what's going on though. So it's always well above my head. It's usually the seniors that are having these questions and talks. I usually just sit there and go, this is great, and take notes and hopefully refer back to it later and make sense of it later, because they've actually, quite a few of the people that I work with find it really helpful if you can take minutes. I know that sounds really boring, but they'll be consistently talking, and they need that captured because it's really imperative to the design process and what you're doing. So you're actually a big player in those meetings, although you may not engage, you actually do quite a lot as well. So yeah.
Building services requires a lot of meetings. You wouldn't want to be emailing other people or suppliers like, oh, I want this, I want that. You would want to call them, make sure they send what you want through. So me inside meetings is different. So I work on a few projects. So the project that I'm currently working on, I'm like the work package manager. So I kind of have to like look after the work that I'm doing on my own and then get it verified. So it depends on what project you're working on and what stage of that project. So I also have other meetings where I can join in with seniors, where I just sit around, take notes, just listen to what they have to say, and yeah, just learn from them how they communicate with other people, other clients. Yeah.
And I am a senior person. I spend a lot of times in meetings wondering what's going on sometimes. So sometimes it doesn't change.
He probably spends the whole day doing meetings and meetings.
A question for Georgina. From an undecided Canterbury student. Did you major in power systems for your degree? In your opinion, how important is the power systems major choice for finding a job?
So I went to University of Auckland, so slightly different to how the Canterbury papers are structured, I'm pretty sure. But yeah, I did power systems and advanced power systems engineering up there. So I guess you could say I majored in it, but that's not an official thing. It's just what I focused on. I found it helpful to get a generic understanding of how they operated, but coming into my job, not really. Like how Neo said, it's about 5% of what you do. So it's good to have the fundamentals. You can do calculations. You understand that electricity moves around. It goes from a generator, transmission, blah, 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 as I've already described. But yeah, it's what you do in your job is completely different to what you do at university. So I had no idea what I was walking into, really. So if you've got an electrical and electronics engineering degree, definitely power systems, people will look at you regardless of if you specified in power systems, because you learn it all as soon as you get there, basically.
Cool. And last question online. This one was for Chris, but I think I can probably shape it for all three of you. What are some of the skills expected when entering into a graduate position? So some top skills that you would encourage people to work on.
I'm not sure. By the time you've been selected as a graduate, when you show up, I think as long as you're willing to learn, and like Georgina said, and Neo said, where you don't walk in there like, I got all A's, I know what I'm doing. If you walk in there willing to go, I know the degree got me here, but now, now it's the clean slate. Now I'm starting again, and you're willing to learn and you're willing to listen and be the one that sits at meetings and takes notes and make yourself useful, then I think that's the most important thing. By the time you've got to the, I don't want to, Chris would probably be, the other Chris would probably be the one who'd know what they're looking for in a grad, because I'm in this position. I was just lucky enough to get selected. I'm not sure what they're choosing. But I'd say they know that you've already got your degree and they're expecting a certain level of that. What you can do is, on top of that, being the one who, like I said, willing to learn, willing to listen.
What was the question again? Oh yeah, what skills? Okay, in your 4th year of uni, you'll hear a lot about this term called soft skills. So that's something that I would focus on quite a lot, because you do the technical stuff at uni, you go through it, you study it, you know it inside and out. Hopefully, I like to think I did, but who knows. But soft skills is something that you need to practice a bit more. So if I'm honest with you, I'm absolutely terrified of presenting. And so that's something that I need to work on. And I actively look for those opportunities because I am not a big fan of it. And I know it's something I need to develop. And so if I had figured that out earlier on, soft skills would have been a big thing I focused on a bit more. So communication, talking to people, presenting, yeah, those sorts of things, as opposed to what you actually learn at university, which is technical stuff, but it's not what your everyday life will be as an engineer. So just something to think of.
I agree with Georgina, soft skills. And you're a great presenter, by the way. Soft skills, just being able to work on a team, collaborate together, be able to understand where they're coming from, not arguing about what they think is the right way, like coming to an understanding, and yeah, just good communication.
Well, I think you all did good presentations. Yeah. Briefly, what I'd look for is people who are genuinely interested in engineering, who are asking the questions and actually want to do it, are fascinated by it, the enthusiasm, because if you're enthusiastic and interested, you'll learn everything because you're hungry. And communication is the other big thing. You've got to be able to share your knowledge, share your ideas, and work as part of a team. So I agree with all the answers previously given. Before I do say thanks, there's one thing that I've kept secret to people. We've got 14 people in the room. How many have we got online, Holly? Now it's all over. 55. So there's 14 people in the room and 55 online. 65. Well, that's not bad. There you go, big audience, and you've done it. We'd love them to come here, and more around the country. Exactly. So, real big thanks to the three great engineers here for presenting. It's never easy, but you did an amazing job. So, I'll give them a quick round of applause. And yeah, thanks everybody, and have a great week.
Essentially,